In the previous video we were discussing about the different example of decomposition reaction, and in this video we will continue with some more examples. In the last video we discussed about the decomposition of calcium carbonate, that is limestone, or in other word you can say that the same formula is of marble also. So on decomposition of calcium carbonate, that is when we strongly heat calcium carbonate limestone, it produces calcium oxide and releases CO2 gas as shown in the reaction. Here you can see here. Now in this video we are going to see some more example. For example, an activity is given in activity 1.6. Take about 2 gram of lead nitrate powder in a boiling tube. Hold the boiling tube with a pair of tongs and heat it. So you can see that decomposition actually means to break decomposition, and the definition of decomposition reaction is that to break the components into, to break a single reactants into two or more products. That is what decomposition reaction means. So here actually if you see that lead nitrate, he has asked you to take lead nitrate powder. Lead nitrate, that simply means PbNO3, that is the chemical formula, and you can see the corresponding reaction which will take place during the reaction here. Means PbNO3 heat Pb, this is whole, means I have just colored in yellow color. So you can see that PbNO3 whole twice gives PbO, that is lead oxide, plus 4NO2 nitrogen dioxide, and O2, these NO2 and O2, these are the two gases which will be released, and this lead oxide, that is the solid substance which will remain in the test tube. So one more thing which you will observe while you will start heating PbNO3 is that it is associated with release of brown color gas, and that brown color gas is nothing but nitrogen dioxide. So please keep in mind the color of this nitrogen dioxide gas, because see in class 10th final exam, in science exam, they do not ask direct questions, they asked only conceptual questions. They used to test your concept, and these concepts will be tested by this single one line questions. For example, here this emission of brown fume, this means what is the color of, means he will tell you that a compound is being taken and on strongly heating brown colored gas is being released. So you have to answer that what is that brown colored gas. So if you are knowing that the brown color is associated with nitrogen dioxide, then simply you can answer that the gas involved is nitrogen dioxide. Now here one more example of decomposition reaction is given, that is the electrolysis of water. Electrolysis, that is simple opposite process of formation of water. For example, formation of water, how water molecule is formed, that is 2 moles of H2 plus O2 gives you 1 mole of means 2 mole of H2O. In a similar way, when we will pass electricity through these water, means that is the electrolysis is the reverse process of formation of water, I should say, or I should say electrolysis is the breaking of water, that is H2O, into hydrogen and oxygen gas. Here you can see the equipment or the arrangement which is required for electrolysis, that is a source, a DC source is there, anode and cathode is there, and 2 graphite rods are placed, and over these graphite rods 2 test tubes are placed. In these test tube, as you can see clearly, in this test tube, in one of the test tube hydrogen gas will be there, and in one of the test tube oxygen gas will be there. So this is also one of the example of decomposition reaction. Here is the corresponding setup what you need to do in order to do that activity is in detail. Now one more example given regarding of decomposition reaction is the decomposition of argentum chloride, that is AgCl or silver chlorides. So what is this chemical reaction? Means here as I have underlined here that the white silver chloride turns grey in sunlight. So obviously if there is already I have told you that if there is a change in color, then that is associated with any chemical reaction. So what is happening is that this AgCl, which is initially in white color. So when it is placed in open atmosphere or in sunlight, then it get decomposed into silver and chlorine. Means this chlorine gas will pass into the atmosphere, and this Ag will remain at in the beaker, or I should say in the petri dish. And one more example is given here. Silver bromide also behaves in the same way, that is AgBr sunlight. This one more thing, in most of the cases you have seen that above this arrow, which is facing towards the product side, so one condition, some things are written over this arrow and below this arrow. So these are the necessary conditions which are very, very important in order that that reaction will take place. So above reaction, one more thing you need to keep in mind related to this exam with this chemical equation is that it is used earlier. We know that black and white photographs were used to come, so this compound was being coated over those photographic plates earlier, but nowadays those photos are being I should say film photography is being replaced by digital photography. So there is a in text question, and I hope you can answer it. So very first is see, this type of questions are only asked in exam. They will not ask you the definitions. They will ask you this type of conceptual question which are based on your understanding of what you have read. For example, here in the first question he has written a solution of substance X is used for whitewashing, and even I have asked you about whitewashing in worksheet 1. So what is this substance X? The very first question is name the substance X and write its formula. So we all know that whitewashing means to cover the house with a layer of soaked lime, or I should say calcium hydroxide. So from which substance this calcium hydroxide is prepared? That is a basic substance from which that is obtained is calcium oxide, or I should say quicklime. So name the substance X here. The answer will be your calcium oxide or quicklime. Write the reaction of the substance X named in one above with water, and in the next question you have to write the reaction between calcium oxide, that is quicklime, and water. So we all know that it will form calcium hydroxide. Next is, why is the amount of gas collected in one of the test tube in activity 1.7 double the amount of collected in the other? Name this gas. So actually this is the activity 1.7 was nothing but our electrolysis. If you see, go back to the previous slides, then you can see here that activity 1.7 was nothing but our electrolysis. And I told you that in electrolysis there occurs a breakage of H2O molecule into H2 and O2. So if you go through the balanced chemical equation of H2O breaking or formation of H2O, so you can understand this from this formation of H2O. In the very first, that is in this reaction, you can see how H2O is formed. That is 2 moles of hydrogen gas. So here you can see that 2 moles of hydrogen gas is reacting with 1 mole of O2 to form 2 moles of H2O. So you can simply answer that 1 mole of one mole of O2 oxygen required 2 moles of H2O in order to form 2 moles of H2O. In a similar way, so in the second equation, that is below the first one, 2H2O gives 2H2 plus O2. This is what the reaction going on in electrolysis. So electrolysis is just breaking of H2 into constituent gases, that is H2 and O2. So from this you can see clearly that if we are going to break, or if we are going to, if suppose if we take 2 meter cube 2 volume or 2 meter cube of H2O, Then if we are going to do electrolysis, then it will produce 2 meter cube of H2 gas and 1 volume of O2 gas. So this is what the answer related with that means. Actually you can see here that if we are going to break 2 moles of H2O, then only 1 mole of O2 gas is released and 2 moles of H2 gas is released. So you can see that the ratio in which O2 and hydrogen gas are released is 2:1. So you can now answer why the amount of gas collected in one of the test tube in activity 1.7 double the amount of oxygen amount collected in the other gas. So this double the amount is of hydrogen. So name this gas, that is nothing but hydrogen. Now coming to the next type of reaction, that is displacement reaction. So displacement reaction, this reaction as usual can be, so basic, if you want to understand any of the type of reaction, just go to the types of examples associated with that particular reaction. For example, here one reaction you are just here one reaction is given that iron is made to react with copper sulfate and it is forming FeSO4 and copper. So actually this is a type of displacement. Displacement means simply this copper sulfate solution is generally blue in color. So when we will put this iron nails or iron fillings in this copper sulfate solution, what will happen is that this iron will displace copper. Iron will displace copper from the copper sulfate solution, and ultimately iron sulfate will be formed, and this copper which is being removed from copper sulfate solution, this copper will start depositing over the surface of iron. And one more thing you will observe is that the copper sulfate which was earlier blue in color will get converted into colorless solution, and same is the thing which is being shown above in these two test tube. So initially copper sulfate solution was there, and in the other reaction mixture test tube B, iron nail with here you can say that initially iron nail was there, and when I will put this iron nail into this solution, please observe carefully, when I will put this iron nail into this solution of copper sulfate, then the final product will be this solution, that is iron sulfate, and this means indirectly whatever copper that is being displaced from copper sulfate will get deposited over the surface of iron. So in displacement reaction, just there is a displacement of chemical elements on the basis of their reactivity. More be the reactivity, more be the more a given element is more reactive, that element will obviously replace the other element which is less reactive. So here some few examples are given: zinc plus CuSO4, zinc sulfate plus copper, lead plus CuCl2, that is copper chloride, it will form lead chloride and copper. Zinc and lead are the more reactive elements than copper. So as earlier just now I have told you that depending upon the reactivity, depending upon the relative reactivity, these reactions occur. For example, here it is written that zinc and lead are more reactive elements than copper. They displace copper from its compound. So it's one of the important lines, so it will be better to underline this. Now coming to the double displacement reaction. So in this reaction you might have observed that here only one single element was there, and that was displacing this copper from this copper sulfate solution. So now we will take two compounds. Earlier we used to take combination of compound and element. Now we will take directly example of, or I should say, two compounds, and now the reaction will be like the element of first compound will be displaced by the element of second compound, element of second compound will be displaced by the element of first compound. So you can see here Na2SO4 and BaCl2 solution was initially taken. Now what will happen is that a BaSO4 will be formed and NaCl, that is sodium chloride common salt. So this barium sulfate is, you can see here the states also. This BaSO4 is solid state, and solid means precipitate. So basically precipitate in chemistry means the undissolved substances which get deposited at the bottom of the test tube. Those are called as precipitate. Any reaction, here one more line is given, any reaction that produces a precipitate can be called as a precipitation reaction. So this reaction in turn can be said in example of double displacement also, as well as precipitation also. Once more I will repeat the definition of precipitate. Precipitate is nothing but the undissolved substances which are formed during a chemical reaction, and they will just settle down at the bottom. So what causes this? That is the important means what is the mechanism behind this is that the white precipitate of BSO is formed by the reaction of SO4 2- and Ba2+. The other product formed is sodium chloride, which remains in the solution. Such reaction in which there is an exchange of ion between the reactants are called double displacement reaction. So I will end this video here.